Welcome to Statics.
Further simplification of a force and couple system. In the previous section, we reduced a system of forces and moments to a single resultant force and a single resultant moment. Some systems of forces can be reduced even further to a single resultant force. If the forces in a system are concurrent, coplanar, or parallel, they can be simplified to a single resultant force acting through a unique point. Let's look at examples of each of these special systems. Let's first look at concurrent force systems by considering a system that is not concurrent. Have you ever seen this type of rotating wheel firework? This particular example consists of 5 little rocket engines mounted around a central pivot. When ignited, each little rocket engine produces a force. The 5 forces acting at the moment arm distance d from the pivot point results in a moment about the pivot point. Note that the lines of action of each force are not concurrent. In other words, they do not all intersect at a single point. Here is a revision to the design on the left. I have repositioned the engines so that the lines of action for each force intersect at the pivot point. Because they all intersect at the pivot point, we can say that this system of forces is concurrent. An interesting property of a concurrent system of forces is that they produce no moment about the point. So this revision in the firework would cause it to not rotate about the pivot. The equivalent system can be represented with a single resultant force acting at point P. Now let's consider a coplanar system of forces. As discussed in the previous lesson, this system of forces can be simplified to an equivalent system consisting of a resultant force and a resultant moment at a point. This system can, however, be reduced further to just a single resultant force. I find it by sliding the resultant force away from the point until the resultant force acting through the distance d forms a moment about point O that is equivalent to the resultant moment. These 3 systems are equivalent. Now let's consider a parallel system of forces. In a parallel force system, the lines of action of all forces are parallel. The system can be reduced to a single resultant force, also parallel to the other forces, and acting at a distance from a specified point. For example, the member on the left is subjected to 3 parallel forces, with known distances from point O. The member on the right is an equivalent system, consisting of a single resultant force acting at point P, which is a certain distance d from point O. The resultant force was found by summing the 3 forces. The location of point P relative to O was found by summing moments about point O. On the left side of the equal sign is each force times its moment arm. All are negative based on the right-hand rule convention. On the right of the equal sign is the resultant force times the moment arm distance d. Solving for d gives the distance 4.44 inches. Now this system is not just a parallel force system, but it is also a coplanar system, so this is similar to the previous example. However, parallel force systems can be 3-dimensional as well. Here a 5 meter by 10 meter plate is acted on by 3 vertical forces. I can simplify the system by finding the resultant force and a resultant moment acting at point O. The resultant force will also be vertical. The direction of the moment vector will be perpendicular to the resultant force, and therefore will be in the xy plane. Like the system of coplanar forces, I can further simplify this system by moving the resultant force to some distance away from point O to get an equivalent moment. If I move the force in a direction perpendicular to the moment vector in the horizontal plane, I can find a distance d where the resultant force times the distance d produces the same moment as our resultant moment. Therefore, I have an equivalent system consisting of only a resultant force offset from point O. In summary, if the forces in a system are concurrent, coplanar, or parallel, they can be simplified to a single resultant force acting through a unique point.